All right, so Nextion displays. They are kind of the latest and greatest thing in displays here in the last couple of years. They've caught on fast. As you'll see from some of the pictures, you'll see some of you were at a meeting where I brought in an MMDVM repeater, personal repeater for DMR, and that's actually this display, and I brought it in. These guys, I don't want to say that they're kind of taking the world by storm, but it's picked up a lot in the last year. Right? It got kind of a slow start. People were kind of hesitant to play with it. It looked like it would be too technical, programming kind of stuff, etc. It's not. It's not at all. It's actually, they did a fantastic job of making it about as simple as a thing like this could be made. And a lot of what it has to do with is the fact that there's a very high capability 32-bit microprocessor on the back of the display. So essentially what you have is an integrated controller and an LCD display with a resistive touch overlay. They go from 2.4 inches up to 7. The 7s originally, I think, went for about $120, but they're down to about $85. Now, a 7-inch display is not something you're going to put in just anything. And after all, a lot of the modern automobile entertainment systems have about a 6.5, 7-inch display. So you're talking about a fairly sizable display. But I'll tell you right off the bat that there's nothing that those entertainment center displays do that you can't do with one of these Nextion displays, and more. Okay. So as we get into it, you'll see why that is. Yeah, man. The 2.4 inch, this guy, goes for about $15. Kind of doesn't matter whether you buy it off eBay or you buy it off of AliExpress. Either or, about $15. So you get the whole full unit, touch, 2.4 inches, full color, 16 million colors, etc., for about $15. Okay, landed price. The 3.2 inch, which is this guy, this is actually what they call the enhanced version, which I bought accidentally, as a matter of fact. They put about a $20 premium above the regulars on the enhanced. And the main difference is it's got a beefier 32-bit processor, but it also breaks out the 8 I/O pins that cover the gamut between pulse width modulated input and output and interrupts. So really, once you start interfacing this to the enhanced to the outside world, you might not need a microcontroller, a separate host microcontroller like the regular ones do. But they'll work with an Arduino, and they'll work with a Raspberry Pi. They will work with basically anything that's out there. If you have a basic stamp, it'll work with it. If you have a PIC, it's going to work with a PIC processor. The only requirement is that that microcontroller has to be able to operate with a 9600 BPS serial link, a 2-wire link. So that's the only requirement. And that pretty much covers just about 100% of the microcontrollers out there. So whether that controller is used in an end product like a Raspberry Pi, which of course has an operating system and everything, that's essentially a small PC, or it's a microcontroller that is like an Arduino in whatever form factor, they all have a serial interface port. So there's virtually no limit on what the host controller can be. The displays are actually set up, the enhanced takes us a little further, but essentially the way you want to think about these displays is they can do everything a user interface, a human-machine interface needs to do by themselves. They do not depend on the host controller. This microprocessor on the back is extremely powerful. It's much more powerful than an Arduino. It has a lot of speed and it has a lot of capability. So that's one of the reasons they came out with the enhanced, and they're coming out with a third model called the intelligent line, that's going to have more I/O and more capabilities, because ultimately what they're trying to get down to is eliminating the host processor altogether and being able to have this be just one single operational unit. Okay, and I think as we go through this, you'll understand why that's important. When you first power these things up after you programmed it, and programming is essentially a function of either uploading over the 9600 BPS line from your PC, that would be your development environment, or using a micro SD card. And all you do with the micro SD card is you put the HMI file that's created from the Nextion editor, which you'll see shortly, and you put it on the flash, you power it up, and it knows to look at flash first, looks for an HMI file, there should only be one, and then it loads automatically from that HMI. So it's a very simple flashing process. There's nothing special that's required for that. If you do want to make it a bit more interactive, there's some advantages to doing it because there's a simulator in the editor that I'm going to show. Then you buy one of these serial UART cards, right? Just these little adapters that do serial UART at plus 5 volts to 0 volts TTL level UART, okay? And they're, I don't know, $4 or $5. They come with a wiring harness, and they come with a little USB adapter. If you use a micro B connector on this, you can power the display from it. You can't upload it that way, but you can at least power the display from that if you want. So it's just a 4-wire interface, 2 power wires and 2 serial interface wires. Right? 2 power, 2 serial interface for transmit receive. And when you put them in and integrate them into a project, you basically only need 3 typically. Typically you're not going to transmit back to the display, receive from the display. You're going to only transmit characters to the display. So we'll cover that here in a minute. But the idea is you get in the editor and you have a palette of built-in objects that you can use to create the page that you're going to create. Okay, page 0 is the first one that comes up when the display is powered up. You can have, I think, up to 8 pages total. It's really dependent on how much flash memory you use and how much flash you get with the display. The basic ones, I think, have 16K of flash, or 16 mega flash. 16 mega flash, and the enhanced, I think, are up to 32. Okay. But essentially, that's the only real limitation is the size of the flash storage that you have available. So you can keep adding pages. All right. Now, what's a page? Well, a page is essentially what you see on the screen. So here we have a couple of BitX display examples where someone took this on as a project to say, well, we've got these BitX QRP rigs. How can I put a sophisticated display on it, right, that looks a little bit more like an ICOM or Yaesu HF rig? So they took this on, and everything you see here is just visually placed, okay? Those are buttons at the top. Those are buttons. Those are just text numbers. This is called a waveform grid. The waveform grid actually, when you send it data, it actually plots a waveform. So the idea is you can make an oscilloscope if you want. So you send it data, and you can plot out whatever data is on there, just like if you were making a small portable oscilloscope. Progress bars that are inserted over an image. So a lot of this is just visual tricks that people that work in user interface development know, like the back of their hand. Essentially, if I put a picture up, and then I put an object like a progress bar over top of it, right? Then all I'm trying to do is I'm trying to insert the progress bar in between those upper and lower reticule lines, okay? And so as the progress bar goes left and right, then it looks a little bit like an S meter, right? Here, these are buttons that have black backgrounds but have a white outline to them. And they're just stacked side by side like Lego blocks. And then there's the text is being written because everything on here that is not just a static image is an object. And those objects you deal with by saying object name, which might be like J0, dot, val for value equals, and whatever it equals. When we'll look at some Arduino code, when you do it in Arduino, you do the exact same thing. And the only difference is you have to send 3 double foxes, right, as essentially a completion character. So when you send a command, you follow it with 0, 0, fox, 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 and that says that's a command. That tells the display it's a command. That's just a protocol they came up with. There's nothing special about that. It's just a serial interface protocol that's custom to the display. These are images, and essentially you can position the image, so the XY coordinates of the image are a variable. So you can essentially alter that, so you can move that block back and forth to show which part of the passband you're in. So they're only really just doing some visual tricks here, okay? But without the numbers in the default state, right, all the basic text that's here, all the basic graphics are here, right? These are fixed. This kind of stuff is fixed. That's what you do in the editor, okay? And then you make it, you lay it out the way you want it for that specific display size and that specific display type. Again, there's a couple types, the enhanced and the regular, and we'll see in the editor how that comes out. The MMDVM example is similar to what I showed last year. You have images at the top that are just fixed. You have a gauge, and the gauge is essentially the needle, okay? So the needle is sitting in front of an image of an S meter. And so as the gauge is given different values, the needle moves like a hand on a clock. It'll actually spin around 360 degrees if you want it to, right? Obviously you don't want it to in an application like this. But again, it's just a visual trick. So, you know, things like an IP address, things like your call sign, gets sent from the host computer over. The flag up there, not sure what country that is. The flag up there is
Portugal.
Portugal, okay, you would know. Is just a static image. So once that image was placed on the screen for page 0, done at that point. When the upload occurs, first of all, the editor will compile everything into an HMI file. When that HMI file is uploaded, everything it needs, all the images, all the pointers to different pages if they're already, all the touch activity, that's all in the HMI file. Okay, so it's a complete deal. Okay, so we'll get into how this works a little bit. The Nextion editor is just a free download, okay? So, like is so often the case nowadays, the vendors that are supplying this technology have the development software available for it for free. Occasionally there's like a pro version of something that you pay a little extra for, but pretty much everybody's got some free version, and that's what IT has done, the company that does this has done, essentially made this editor a free download, okay? So you can get free examples, so you don't have to start from scratch, and you have all the documentation, which I'll show you, that's on there, in their wiki, and the free editor. And the editor also has a simulator, which I mentioned a couple minutes ago, and the simulator will do everything as if there's a host controller there, okay? So all the interactivity, the touch on the screen and all of that, whether it's handled completely by the display, which should be your first rule, right, your first option, or the host processor does things, you can set up the simulator to do all of that. So essentially you can test the whole thing before you ever hook it up to an Arduino, for example. So it's a very nice development environment. Okay, so I'm going to sit down here so I can drive. The editor is this guy. Okay. Oh, nice retrace lines. Let me walk you around some of this. Probably going to have to shrink this a little bit because of the resolution of the display. The toolbox here over on your left, this is, for those of you that don't program, this is a very common metaphor for development environments. You have a set of things on the left and a set of things on the right, maybe something on the bottom, and really what your focus is, of your attention is in the center. In this case, in this graphical designer, it's not unlike picture editing software, same kind of idea, where you have a toolbox that gives you various things, like the waveform, which is like the oscilloscope, the gauge that has the needle that goes, the pictures, the progress bar, which I'm using here, this is J0. T0 and T1 are just text boxes, and I have a button up in the upper left-hand corner just for the purposes of showing you something a little bit later. That, other than, well, I'll include the learning. I started with this from zero, right, from scratch, read some of the documentation, understood the basic concepts, and put this together in 2 hours, okay? Now you can say, well, maybe that took you 2 hours, it's going to take me 4 hours or whatever. It doesn't matter. The point is on a Saturday and Sunday morning, you can dive into this and get something going right away, something simple. And the rest of it is really left to your imagination, okay? Now, being that we're technical guys, our imagination is a little different than an artist's imagination, right? Just a bit, right? My daughter's into art, and she couldn't be more different that way. When she does web page design, she comes up with things that just blow my mind, and I think, well, how did you come up with that, right? Because I can't relate to that, right? So some of that is the challenge with these displays, where you have to think about, well, you know, what's my starting point? What's my design? Am I going to scratch it out on paper first and think about it? Yeah, that's fine. But there's so many examples at this point, and we'll look at a few here. There's so many examples out there now that you can probably find a starting point, either in some of the examples or in the real world. This happens to be roughly the same display on my Agilent 441 power meter. That was the starting point, right? All I did was try to emulate what I was seeing on my test equipment, right? So, fine, right? Now, it's not fancy at all, right, but that's fine. Is it functional? Yeah. And compared to a 2-line LC character LCD, it's a little better, right? Because I don't have to, if I want a bar graph, I don't have to make character boxes go across the display in my Arduino code. I don't have to change things and update things, and then if I want to change the units, then I got to add a button, a physical button, to go change the units from dBm to microvolts, right? This, I just touch the screen and all that happens for me. So it's very powerful. Let's see. I'll show you some examples here from the web. Once you get into this, what you typically want to do is, it's not showing up terribly well, but you Google Nextion displays and click the images tab at the top. And there are page after page after page of these pictures that people have taken of weather station displays, ham radio applications, again for the BitX with some variations that people have made. That's typically what happens is someone does a project like this initially, everybody grabs it, and as soon as you get the HMI file, you have the source. It's not compiled in a closed source way. It's compiled in an open source way, so you just grab their source. You say, okay, I like this, but I want to change this one thing. You load it in the editor and change that one thing, and you reload it into the display. Okay, so that's what everybody's doing basically with the BitX. Here's something it's a game, you know, using some cartoonish kinds of characters. One of the built-in, not in Chinese actually, but in English, one of the built-in examples shows graphical buttons, right, where they have an icon in the middle of the buttons. And that's all done with white buttons as a background and icons put in the foreground. Okay, that's how you do that. With some text underneath. The background, the nice background picture, is a picture. So again, it's just layering. You put the backmost image in the back and then start layering on top of that, much like if you were building a cake or anything like that. You're going to layer it on top. What else we got? People have done keyboards, on-screen keyboards. That's not very large. People have done little projects with Arduino similar to what I brought, where they put it on a breadboard and they've got the display and everything. This is a GPS-driven clock. Should be in a nice case, I would say. Let's see. So there's really no limit here to what you can do with these. This was one that I had sent out. So if you can also take a rig that you have that has an LCD display, and as a project to challenge yourself, say, okay, if I got the code for the micro that controls it, which oftentimes you do, this wouldn't make sense if you didn't have the code, how would I add a Nextion display to it, right, and get rid of the two-line character LCD? It's not that hard. And while I'm at it here in the browser, AliExpress, if you, again, just type in Nextion display or displays, there's dozens of vendors that sell these, and they're all pretty close in price. So eBay and AliExpress are two good sources. Oh, I should show the starting point for the quick start in wiki format. Goes through everything where it talks about starting in the editor itself. How do I start a new project? What the various areas of the editor are. And it talks about all of that, what functions are there, so on and so forth. So it's one of these kind of technologies that you pretty much just got to dive into, really. And as you dive into it, you find out it's not that complicated. The documentation is good. It's not fantastic. It's not the best I've ever seen, but it's pretty good. It was originally done in Chinese, and then it was translated into English by a group of people, so that be more helpful to us folks here in the States.
Is it a good translation?
Yeah, yeah. There's a little bit of missing articles and vowels here and there, but not much.
Okay.
It's a good translation. Not to the point where things don't make sense or it's gibberish.
Okay.
So, probably more than anything, just oversights. Now the debugger, as I was talking about, I wish this were a little brighter, unfortunately. It's not. The debugger allows you to set things explicitly, so you'll see, hopefully you can see that, it's not too low. When I start typing a variable name, it actually gives me a hint as to what objects I have that begin with a J or begin with, and it's essentially, you know, B is for button, T is for text, J is for progress bar for some reason, don't know why. Perhaps the Chinese word for progress bar begins with a J, I don't know. But you would type J0, and then it'll bring up the methods and the properties. In this case, I want a value, and that the hint says progress value. Oops, thought I selected that. And then an equal sign, and then some number, and hit enter. And then it just sets that value to that progress bar, right, which is essentially 0 to 100. If I put a value of, say, 123 in there, then it comes back with an error. Now, yes, it's a hexadecimal formatted error, but it does tell you down here that the operation failed. And what that means can be looked up in the Nextion guide, okay? It's an out-of-bounds value for that object is all it is. So rather than kind of faking it, it just throws an error and returns it back to you to say, okay, fix this. So there's 100%, we can go back to 0, so on and so forth. Now, I had set this up so that if the background is touched, it'll change color, right? So it'll just change color by touching the background. I can make any area on the screen a hotspot of sorts, so that when I touch it, I can change. So if I want to change dBm to microvolts, I just make that a hotspot, and then when I touch dBm, it goes to microvolts or vice versa. Now, I think most of you know that converting from dBm to microvolts is a little bit more than just basic arithmetic, but it's not that difficult either. So as it turns out, long story short, you can actually put the formula in here, because you can say set this object to a value equal, and rather than a hard value, you can set it to take the other value, right? So it's like value equal value plus 1 kind of format. Take the value and put it in the formula, and then return that to that value, right? So it will actually convert dBm to microvolts and do it at the display level, and I never have to put the code in C++ in Arduino. Rob?
How quickly would the cycle time to go through the program?
Microseconds. So, yeah. So when you do stuff like that and you touch, the response is within the blink of an eye. So it's definitely adequate. The processor's clocked at 120 megahertz, so it's got a lot of CPU bandwidth. Larry?
Okay, now that you've got touching with the computer, is there any way I can feedback to the host that you're connected to?
Absolutely.
So you can go back there and...
Absolutely. So basically...
You run something else.
Yeah, so a little high bandwidth here for you. You can set up interrupts that go back to Arduino, right? So even though it's going across a serial line, you can set up a software interrupt and essentially hit that software interrupt to trap it, and then have the host processor handle that trap on a touch. And 9600 is not blazing fast, but it's fast enough in this kind of application that it gets over there and processes relatively quick. I mean, when I say relatively, I mean, again, within a blink of an eye or two. So it's fast enough.
Russ, for some reason, touchscreens and I don't mix well. I usually get to the point where I want to pull out the bolt and hammer.
Yeah.
Is there a way to change or adjust or modify the sensitivity?
Yeah, there is. In the page has a bunch of properties that are outside the scope of this presentation, right? But there's a bunch of properties, and one of those is to set the sensitivity on the resistive touch screen, okay? If you left the film, the protective film on, it'll still work just fine. It's sensitive enough to do it with the film, right? So like grandma's chair that has the plastic cover over it, right? You could leave it on forever, right? Even though it's kind of diffusing the light coming through it. You peel that off, and let's say that's too sensitive. They've done an excellent job with the haptics on this, so I have not found a case yet, right? My son tends to have moister hands and fingers, and he's done it without any trouble. I've done it without any trouble. Mine tend to be dry. So to kind of give you a feel for that on the range of things, pretty good. However, on a display like this, I have smaller fingers, which is great for electronics, but the average size male finger is going to, so on a display like this, it possibly is too small for your application. So you do have to think about it a little bit. How big is the hotspot that I'm going to touch? Is it like, you know, the size of, 4 pixels? No, it can't be that small. You're just never going to hit it, right? But if it's the size of the tip of my finger, then no problem. So if it's an image I'm touching, or I'm touching a gauge to adjust the dial, or I'm sliding something, right, the way it works on Bidex, then what's going on there is, and back to Larry's question, is that you essentially now are taking that feedback supplied by the human, and you want it to go to the host processor because you're trying to tell it to do something, right? In this case, adjust the tuning range within the passband, right? So you want to shift it right, you want to shift it left, up or lower. You should be able to just touch and slide. So you touch it, hold it, and slide, right? Again, I have not found a case where it didn't work adequately, I thought. In fact, I put this button up here that you can't see. Again, another little visual trick. If you're going to put something hidden, then make it the same color as the background, right? And you know where it is, and that's good enough. If you were making a product, you would never do that, right? Because it would be too obfuscated. But for your own use, you can set that up and say, okay, that's how I get back to the base color, and I can do that all day. Now, a pointer from a mouse isn't quite the same as a finger, right? So then you load it and you try it, and because I put it right smack in the corner on purpose, right, you'll find sometimes that if you're too close to the corner, it does not sense enough of your fingertip. So you want to be a little bit away, right? So there's a little bit of trial and error is what I'm saying. And that's a rectangular button. It could be a square button, and it could be the size of a dime, let's say, and I could probably hit it 100% of the time. But I purposely made it small to kind of test what you're asking about. Okay, so other questions at this point? Okay. Let me show you the Arduino code, but I first have to give you a little context on this. Like John, or not unlike John with the QEX article, I had come across these 8307. Many of you are familiar with the chip from Analog Devices. It's a logarithmic power detector, right? I think this was $7 from AliExpress. Okay, so just a little module in it, covered with a can, add 5 volts, and it has an output. It's a voltage that has a proportionality relationship to the power level, right? Power level's logarithmic. What the chip does is take that logarithmic input and make it linear. So it's essentially turning it into a straight line so you can deal with it easier, right? So you're not having to deal with exponents or logarithms, right? So it's making it linear. So what you get is a linear voltage that goes from the bottom of this, which is minus 75 dBm, okay, so that's just under S9, all the way up to plus 17 dBm, okay, which is pretty high, right? 0 dBm is 1 milliwatt, right? So you're up there pretty high with 17, okay? Now I had intended, it would take me a minute and a screwdriver, which I may or may not have, to hook this up, but essentially what I was trying to do is take the Nextion display and emulate that piece of test equipment I mentioned and get both the analog bar graph, right, of the output from the detector as well as a text output for the detector. And if I touch the background, I get the change that I showed you, right? If I touch the upper left-hand corner, I get that. And you can see the response time on just this internal processing is very fast. Again, it's got a very fast processor. You know, it's somewhere between an Arduino and a Raspberry Pi. So, I mean, it's really cooking. So there's plenty of horsepower there. Right now, the input to the Arduino is floating, so that's why it's going up and down, but it kind of illustrates the point pretty well. I found, by the way, with this module, that compared to my Agilent power meter and my Fluke signal generator, or RF signal generator, that this was dead on. When I put it together from minus 75 up to plus 17, whole numbers, not decimals, okay, so minus 75, minus 74, minus 73, all the way up, it was dead on. So with an $8 module, you've got the accuracy at least of what used to be called an HP 435B power meter, which was an analog with a needle. And they're very precise. Given what it is, it's amazing, like if you set an output and measure it to say minus 10 dBm, damn if it's not on minus 10 on that needle. So very accurate, but this is every bit as accurate. So for $8 an Arduino and a $15 display, you've got a RF power meter, that rivals something that's 30 plus years old, which isn't that bad. It sounds like, okay, it's 30 plus years old, blah, blah, blah. It's not going to be as good as the ones with the sensors and all that. Well, no, it isn't going to be, but those cost, $2,000 too. So if you want accuracy to 2 decimal places, then you're going to spend the money. But if you want accuracy to no decimal places, just to whole numbers, you can get it for about 25 bucks, which isn't bad. And minus 75 to plus 17 is a good range. Again, that's about just under S9 to, what would it be, about 40 over, 30, 40 over S9. So, pretty good range. So that was the inspiration, and by the way, that'll be offered for this fall build-a-thon. Again, whether go with a case or not, it'll be about a $25 to $30 kit to do it. The microcontroller I would use would not be an old Uno, but I would probably use a Nano or one of the newer ones that you can get for $4, right? Because there's plenty of them that you can get for $4 that have Wi-Fi and everything for $4. So, and they program with the Arduino integrated development environment. So like I say, for about $25, $30, we can put together a kit that's, give you a nice power meter.
What's that device that you were holding up called when you together?
This guy?
Yeah.
Yeah, so I will put a link out. So the presentation's going to get uploaded to our website, and then I'll put a link out on this. I forgot to put it in the presentation. There are links to the other things, the displays, the editor, and some of the examples that are out there. And if you do some Googling around, you'll find there are whole libraries of these things out there now. You can find, depending on the application you want, let's say you want to make a weather station, you'll have 100 different examples to choose from, easily. And so if you don't want to get too creative or just want to interface it, you can grab one of the examples you like and then read about how to interface it to the Arduino so that you can send it temperature and humidity or whatever you're trying to do. Done. So it's a pretty cool technology. Pass this around. Thank you.
What's the power dissipation when you're running these? So, you can run it off the USB 5-volt type thing.
Yeah, 12 milliamps.
So, running that processor or both?
Yeah, it's a low power CMOS version, so yeah.
Yeah.
Yeah, so probably the big hog there on that display is the backlight.
Can you adjust that?
No, strangely enough, you can't adjust the backlight. They may change that later. I have not seen any contrast issues, but maybe in a dark room or something like that, it might bleed a little, right? So I don't know, but
Or LED for the generation 4.
yeah, right, exactly. Right.
On your converter there, you terminate the input with precision 51?
It is terminated.
It's already terminated.
Yeah, it's already terminated, so it's ready to go. It has, you'll see as it goes around, it has an SMA connector on it. It's all terminated, 5 volts, and this is the voltage output is ready to go.
It's 50 or so compared to...
Oh, it's dead on.
Absolutely dead on.
It's dead on. Yeah, I know.
You can't complain.
Not hardly. I mean, I didn't know that when I tested it initially.
Right.
So I set it up, had to get it so the formula in my Arduino code came out so that, you know, it tracked, right? Because I knew what the power level going in was, and so I had to get it to track. And when I got it to track within a few dB, then I ran up and down the range and I couldn't get it to go on. And I was like, holy shit.
And what's the frequency range?
500 megahertz down to DC. That's just the chip. The 8307 covers that kind of range. So I ran it. I did do some testing to see how linear it was at different frequency bands. So down in the low HF at about 5 megahertz, it would go off a little, and then it would go off a little at over 400 megahertz at UHF. But not much. I mean, just a smidgen.
You've got experimental methods from our design.
Yeah.
We've done a whole lot of.
With that chip.
Yeah.
That's right. There are a lot, I'm glad you brought that up, I hadn't even thought about that. There are a ton of test equipment ideas in that book that if you put a display on, that's a decent test bench. That was some of the limitation back then when they wrote that book, is you didn't have all this technology to throw at it.
I think they used 1 milliamp
Meter, right. So, I like analog meters, that's why I put it on the field strength meter, because you kind of want to see it swing. But with something like your measurement, it's okay, it's stable, right? So you're going to have coming in, it's going to stabilize to a particular point, you got your reading, right? So if you have a signal source that you build, you could trust that to say, if this is minus 73, then I got an S9 output, right? So I know what I'm dealing with there. And again, to get any more accuracy, you're going to go up thousands of dollars. And it isn't worth it. Plus you have to calibrate those things every couple of years, so it's just not worth it. But again, for 25 bucks, who can complain? Now, with that, you can also do some other things. You can put a preamp in front of it, you can make a field strength meter out of it, you can do all kinds of things at that point with that base design if you want to. Others have used these displays for VU meters. So there's circuits out there to run a VU meter through an Arduino and have it display for the audio people. Who come up with some crazy combinations of things where they'll have tube type technology for their amps, but they'll use an Arduino for the instrumentation. Right? They'll have soft buttons and everything for the front of it and have it look very spiffy, but yet there's 6L6 tubes in there. Right? But yeah. So that's pretty much it. Any other questions?
Is it too early to get on the list for the kit for the ball builder fund?
No, I've got that solid now that I'm shipping. So.
For the fall builder, I think we from the radio that Steve showed us last, and then,
Oh, the 5.2?
5.2. Yeah.
It's cheap and you have a real feeling of accomplishment, you get a call.
Yeah, actually.
I commented, I sent a note to Craig on that. I said, please bring good directions in English. And that means please.
Not looking at the coding instructions.
Yeah.
My brother speaks Chinese, so I leaned on him a lot. I sent him a copy of it.
So you're going to sign up to rewrite the manual.
Yeah, maybe.
Well, that's a great suggestion, because actually you can tell from what I showed that we have that as a kit for the fall. It's going to take you 5 minutes, but there's not much to it. And obviously you're not going to write your own code when I've already written it, and it's like 25 lines of code, so I mean, there's nothing to code. So,
You could spend a long afternoon with everybody programming it.
absolutely, if you guys would be interested by that time in saying, well, you did this presentation in January, but I haven't really had time to fuss with this. Do we go through it as a lab? I'm willing to do that. It doesn't have to be built upon either. So, yes, Dan.
I think I missed something. You mentioned about the BitX.
Yeah, all of those displays I was showing with the meters on them and stuff were done for the BitX. And if you Google BitX20 or BitX, just BitX, you'll see the board. And I think it was Craig a couple months ago that brought one in. Someone brought one into a meeting we had. So you might look in the minutes back a few months, and Steve probably took a picture of it, I'm sure. So.
Okay.
Yeah, it's like about a 7 by 7 inch board, something like that. Might be smaller. Okay. 6 by 6 or 5 by 5.
I remember it being like a QSL card.
Yeah, the QE, he was asking me about the QEX, the new Hans Summers one, and I said the BitX is kind of similar, but they both are somewhat limited on bands in terms of how many coils and how much switching you want to do. You know, that's the part they kind of leave to the user to figure out. You know, but you know, as we've talked about before, if you're in an apartment, you're probably going to want to go on 20 meters for the most part anyway. You have a fairly short line of wire, and on 20 meters you can work the world and have fun. So, anything else? All right. Well, if you need any help, if you do want to get started, don't hesitate to reach out to me. Okay, I can get you started or whatever on it. If you need some ideas or inspiration, I'll provide that for you. Okay. It's great technology, and I hope some of you grab one.
So how much was that 3-inch deluxe display about?
This guy is 25 bucks, yeah. About 20, I think 23 on AliExpress delivered. Isn't that something?
That's a bargain.
Yeah.
Well, yeah, I mean,
The official on their website for 3.2 is 2240, and the
Yeah.
advanced is 2740.
yeah. Thanks. Yeah, I'm anxious to see when they come out with the intelligent, what all it's going to be able to do. But I honestly predict, you can mark my words on this, I'm sure the intelligent is going to be completely standalone without a host processor, because that's where they're heading. So if they make it compatible with the Arduino IDE, they're going to have something. You know, can you imagine just plugging a USB cable on it and being able to program both the display and the host code? Away you go. So it's going to open up some interesting applications, I think.